All right, hello. Thanks for the opportunity to present to you today. So I'm Dr. Missy THOMPSON. I'm an assistant professor of biomechanics at Fort Lewis College, and on behalf of my co-authors, I'm going to present to you today our research titled The Biomechanical Analysis of Mixed Climbing Performance. So many of you are probably not familiar with Fort Lewis College. So Fort Lewis College is a small public liberal arts college located in southwest Colorado, Durango, Colorado, which you may be more familiar with. Durango, Colorado hosted a round of the World Cup ice climbing competition in 2016, and that really was what led to us, our idea behind the study. So we saw the elite high-level performance here. Unfortunately, we also have a consistent elite competition, ice climbing competition, at the Array Ice Park, which is just up the road from us. And so that's where we were able to conduct the research for this study. Before I dive into describing the specific, our specific study, just a little bit more background about the sport of mixed climbing and some of the research conducted in this area. So the sport of mixed climbing has really seen rapid growth. So I'm sure you're all aware of the UIAA's efforts to get this included in the Winter Olympics, as well as it being a demonstration event at the Sochi Olympics. And really with this increased popularity and this push for Olympic inclusion, we're starting to see more research in the area of climbing in general, but also specifically to mixed climbing. And so obviously we see that in terms of conferences like we're at here today. And in regard to looking at some of the climbing research, a lot of it is focused on analyzing performance, right? But what we've seen a lot of is that a lot of the research is focused on looking at the differences between novice and more experienced climbers. But really, if we want to look at elite performance, we really need to look at elite competitors, because we've seen in other sports, for example, running, that if we look at performance factors within an elite population, those differ from the factors that distinguish between more heterogeneous performance. So for example, if we look at VO2 max, that can clearly distinguish between a novice runner and an elite runner, but it's pretty homogeneous if we look at a group of elite runners. So we really need to look at parameters specific to elite competitors. And so in general, a lot of the research that has looked at analyzing climbing performance has examined two key areas. So it's looked at analyzing movement, which we've seen some discussion of today, and also looking at physiological factors. And so we see that it's been previously shown that when we look at the differences between novice and elite climbers, or novice and more experienced climbers, we see that they tend to exhibit greater variability in their limb movement. We tend to see that those more advanced climbers tend to have more continuous movement. However, we haven't seen much in terms of analyzing movement in, again, a more homogeneous group of elite climbers. Looking more at the physical characteristics, we see that greater finger strength and arm endurance is a characteristic of more advanced climbers. We also see lower calf circumference, and then also we see much thicker finger pulleys, up to 82% thicker when comparing climbers versus non-climbers. Particularly looking at ice climbing, there's really two really important aspects of ice climbing are the strike motion, and as that's important for placing the ice tool to a sudden route. And corresponding with that, we also have the arm position, and in particular looking at the shoulder and the elbow angle. And so previous research has shown that when we look at, we can differentiate between what's called the cocking phase, which is bringing the ice axe to its most posterior position, and then the striking phase, which is the actual anterior movement striking the ice. And looking at the comparison between advanced and novice ice climbers, there's been previous research to show that they differ in terms of these two characteristics. Despite the research showing the position of, or ice tool, ice use position differs between these different climbing levels, there's really a scarcity of research examining arm position. And in particular to ice climbing, one of the kind of primary techniques that's suggested is to rely on more extended arm positions. so extension at the elbow and the shoulder, because it's thought that this places more of the loading of the body weight on more passive structures, so tendon and ligament, rather than a more flex position, which is going to require active musculature and is going to lead to correspondingly more rapid fatigue. And so kind of the three main areas that led to the purpose of this study, the lack of research looking specifically at an elite population, little research examining the use of these extended arm position, and then also a lack of research in an actual competitive environment. And so that led to our purpose, which was to conduct a biomechanical analysis of climbers during an elite international mixed climbing competition, and to assess the relationship between these biomechanical variables and their overall climbing performance. And we were able to conduct this research during the Array Ice Festival elite mixed climbing competition to get some real competition results. So our participant pool for the study consisted of 24 climbers that volunteered, and these were all competitors in the competition. This consisted of 16 males and 8 females. And males and females in this competition climbed the exact same route. So we did a secondary analysis, and we found no statistical difference between the males and females, so we grouped all males and females together for this analysis. But it is important to note that that's something that should clearly be examined in future research, just to look at gender differences. The group was relatively heterogeneous in terms of age, height, weight, but the key characteristic is that they were all high-level participants. So their performance level was relatively homogeneous. Then we also, for a sub-analysis, we categorized participants as elite, and those were participants that finished in the top half of the overall competition, and then advanced, which is just a loose term to mean that they finished in the lower 50%. But again, these were all relatively high-level climbers. And so during the competition, we recorded video data from 2 cameras that were placed at fixed locations on the side of the canyon opposite from the climbing route. The climbing route is mostly natural with a man-made feature at the top, and so we were able to fix camera positions on this side opposite. We had to use 2 different cameras because we had battery failure due to the cold temperature, but the cameras were maintained at their fixed position. And they recorded continuously. They weren't moved throughout the competition, and both cameras recorded at 120 hertz. So here you can see the analyzed section. So the basic overall climbing competition route starts off on ice, a small section of ice, and then the majority of the climbing competition route is on rock. And so we analyzed 5 different holds, and these holds were selected because they were holds that all competitors used. And these were, and then also 2 clips as well. And so our now analyzed section included that ice section at the bottom and then the majority of the rock section, but we excluded the upper section, which also all competitors completed this full section. So above this is where competitors started to fall off. So we didn't use that for analysis. And so we used the video analysis software Kinovia, and we obtained kinematic and spatial-temporal measures. So our kinematic measures consisted of the elbow angle, which was simply the angle between the forearm and the upper arm. And then we had a global shoulder angle, which was just the angle between the upper arm and the torso. And so we should note that the shoulder angle, we didn't differentiate the plane of movement. Perhaps if we had a drone, we could get a little bit better in terms of planes of movement with the shoulder angle, but we just simply did a global angle, which in this case was all right because we're just looking at that extension position. And we measured the shoulder angle and elbow angle at each of those 5 analyzed holds, and we measured it at the point at which the individuals were weight bearing on the ice tool. So in addition to those kinematic variables, we measured a number of spatial-temporal variables, which basically consisted of the time spent climbing and the time spent resting, as well as the number of moves and the number of rests. So we defined a move simply as when the climber was securely in contact with the wall with either the ice tool or the hand. And then movement was defined as a climber making progression relative to the rock towards the next hold on the route. And then resting was just defined as a static position, so they could move their limbs, but they were static relative to the root. And so we calculated Pearson's correlation coefficients to examine the strength of the relationships between the measured variables and performance. And then we conducted independent t-tests to look at the differences between the elite and the advanced groups for each of the measured variables. And we defined statistical significance as p-value less than 0.05, and that correlated with a critical R value of 0.4. All right, so looking at our findings, we had numerous variables that we collected, and so we've kind of narrowed this down into kind of our key findings. So first is that we, in regard to our kinematic analysis, which again we were looking at the shoulder, the relationship between the shoulder and elbow angle at the point of weight bearing on the ice tool. So here we found a significant and strong correlation between the elbow and shoulder angle at several of the analyzed holds, so those 5 holds that were selected for analysis. And so in the figure here, we see a representative example at hold number 1. Again, we're looking at the elbow angle and the shoulder angle. And we see that individuals are relying on fairly extended elbow and shoulder angles, so indicating that they are using that extended arm position. In this case, we have a very strong correlation with an R value of 0.75. It certainly makes intuitive sense that we would see a coupling between these two joints, as to extend the overall upper extremity, we want to see both of these joint angles increase together. However, when we look at the difference between elite and advanced climbers, so again the top and bottom 50% competitors, we saw no difference in terms of performance here. So really indicating that this isn't a major performance factor that distinguishes elite performance. It's really relatively homogeneous. Both what we consider the advanced and the elite climbers were all using this extended elbow and shoulder position. So this finding of this significant correlation between the elbow and shoulder angles kind of suggests that we have this coupling of the elbow and the shoulder to achieve that extended weight, that extended upper extremity position as the individuals, the climbers, bear weight on the ice tool. And really it's thought that this relying on extended positions like this place more load on the passive structures of the skeletal system, so bone and ligament, rather than relying on active musculature, which we would see in a more flexed position. And by utilizing that more extended position and relying on passive support of the body weight, it's going to ideally lead to less fatigue. But again, this really wasn't a factor that distinguished performance within this elite population. It was relatively homogeneous amongst this group of elite climbers. And so while this isn't a distinguishing factor in terms of performance within elite climbers, it may be something that's trainable in terms of novice and separating novice and elite climbers. It may just be to the point that the level of these climbers that they were at, that they've all trained to this point where they utilize that position pretty consistently. It's also important to note that we only analyze the point of weight bearing. And so there's certainly other metrics in regard to this extended arm position, for example, the time spent in that extended position, which may be a better metric to assess and differentiate performance within this elite population. And also utilizing EMG analysis would certainly be the most accurate way to get an idea of the use of this extended arm position. So in terms of our spatial-temporal parameters, the results of the independent t-test showed statistically significant differences between the elite and advanced climbers in terms of the total number of moves on the route, which again, remember that a move was defined as securely contacting a hold. And specifically what we saw was that the elite climbers used significantly fewer number of moves than did the advanced climbers. Additionally, we found statistically significant differences between the time taken between clip 2 and hold 5, which essentially spanned the entire section of the rock portion of the route. So it just left out the ice portion at the bottom of the climb. And again, here we saw that the elite climbers were moving significantly faster than the advanced climbers. We also saw a significant correlation between the number of holds used and the time spent climbing, indicating that there's a likelihood that the faster climbing speed was achieved by using fewer holds. And so our results in terms of the spatial temporal analysis indicate that movement time and the number of moves is an important performance factor in terms of elite performance. So this is one of the factors that did differentiate between what we're considering these advanced climbers or slightly less elite climbers and the more elite climbers. And in particular, the elite climbers move significantly more quickly and utilize fewer holds than did the less elite climbers. And so there's several possible underlying factors that may explain this faster movement in the elite climbers. First, it may just simply be the ability to read the route more effectively. It really appeared that when we were analyzing the more elite performance, that these individuals were more direct in their climbing, and they spent less time exploring the route. Part of that may be due to the fact that a lot of competitors come to this competition year after year, and the lower portion is identical. It's rock, so it doesn't change. And so they may have more experience having seen the route before. Additionally, strength factors are certainly can be a component to that climbing speed, and in particular by being stronger climbers may experience less fatigue, but we also may see that climbers attempt to move faster in order to minimize fatigue. And lastly, technique differences may allow for better application or more effective application of force, and subsequently more effective movement, less wasted movement, which could potentially result in faster movement time or more effective movement. So to summarize, the purpose of our study was to conduct a biomechanical analysis in a high-level competition. In particular, our aims were to, one, examine a homogeneous group of elite climbers, and also to assess the use of these more extended arm positions. We did find that subjects generally use the more extended arm positions, in particular that we saw that those elbow and shoulder angles were large, indicating extended positions, and they were coupled, indicating the whole upper extremity was extended. However, we didn't see any difference between the advanced and elite competitors, indicating that this isn't a factor that's going to distinguish elite performance, but it is potential that mixed climbers may improve performance by utilizing these more extended arm angles while climbing. And again, it's thought that that's likely due to saving energy by relying more on passive structures. We also found that elite climbers climb faster and use fewer holds than less elite climbers, suggesting that mixed climbers should focus on decreasing the number of moves and increasing climbing speed in an effort to improve performance. And so while we succeeded in our analysis in conducting this analysis of a relatively homogeneous group of elite climbers, the variables that we examined in the present study were by no means an exhaustive list, but there's certainly many more other components that would be important for performance, and therefore future research should really be directed at tackling some of these future components. So certainly looking at the time spent utilizing that extended arm position is an important factor. Also, we only looked at the spatial-temporal factors and kinematics of the upper body. We certainly know that lower body movement, foot positioning is going to be quite important, as well as the overall movement. And there's been some previous research examining at overall movement strategies. And then certainly ice tool use is going to be an essential component of assessing mixed climbing performance. Also, we know that it's highly likely that performance is multifactorial, so we're using more sophisticated statistical analysis to get an idea of the the relationship between various components. So we plan to use regression analysis to further analyze our findings. And then also, while conducting research in an actual competition environment has its benefits, and that we're actually seeing a true competition environment, it is important to combine this with controlled laboratory studies where we can get more specific and eliminate a lot of these extraneous variables. And so certainly examining aspects like the timing and application of force, as well as EMG to get a measure of muscle activation. And so with that, I will thank my funding source, the Fort Lewis College Faculty Development Grant. The Ouray Ice Park, if you are an ice climber, is certainly one of the top places to go. They were instrumental in allowing us to conduct the study. During a performance center helped with the analysis, and then Kurt Blair, the San Juan Mountain Guides, was hugely beneficial in helping us with camera placement and also pilot testing for the study. With that, I'll open up.